We are starting to learn about things called polynomials. They might sound hard, but they are used in lots of things around us. To make them easier to understand, we're going to use algebra tiles. Imagine little squares and rectangles that represent parts of the polynomials. One big square means x squared. A rectangle means x. And a small square means 1. The shaded ones are negative. The tiles can make operations on polynomials easy to understand and follow. We use these tiles to see how to add, subtract, and do other things with polynomials. When we add, we just put the tiles together. When we subtract, it's like adding the opposite. We flip the tiles. By using these tiles, polynomials become like a fun puzzle we can solve with our hands. It makes the math easier to see and understand. So, can you represent the following quantities using the tiles we discussed earlier? So, let's represent x minus 2. To represent x minus 2, we get 1 positive x or the unshaded rectangle and 2 negative 1 tiles or the shaded small squares. So, how about 4x plus 1? To represent 4x plus 1, we get 4 positive x or the unshaded rectangles and 1 positive 1 tiles or the unshaded small square. So, are you ready to use the tiles to perform the operations on polynomials? So, if you're ready, let's begin with round 1. Now, try to solve these following polynomials using the tiles to perform the operations on the polynomials. So let's try example number 1. 5x plus 3x. So as you can see, they are both positive x. So we're going to use unshaded rectangles. So for 5x, we need to use 5 unshaded rectangles. And for 3x, we need to use 3 unshaded rectangles. So, if we combine 5 unshaded rectangles and 3 unshaded rectangles, we can get 8 unshaded rectangles. Since there are 8 positive x or 8 unshaded rectangles altogether, therefore, 5x plus 3x is equal to 8x. So, let's try example number 2. 3x minus 4 minus 6x. So for this, we just need to have 3 unshaded rectangles to represent 3x and 4 shaded small squares to represent negative 4. And we're just going to subtract it from 6x, which is 6 shaded rectangles. Recall that combining positive x and negative x will result to 0. We have 3 unshaded rectangles. So for us to eliminate those rectangles, we need to add 3 shaded rectangles. So the tiles that are left are 3 negative tiles and 4 negative 1 tiles. Therefore, 3x minus 4 minus 6x will result to negative 3x minus 4. So let's try to solve example number 3. 2x squared minus 3x plus 2 plus 3x squared plus 2x. So to represent 2x squared minus 3x plus 2, we're just going to put 2 large unshaded squares, 3 shaded rectangles, and 2 unshaded small squares. So for us to represent 3x squared plus 2x, we just need to put 3 large unshaded squares and 2 unshaded rectangles. So note, combining positive x and negative x will result to 0. So these are the tiles that are left. There are 5 positive x squared tiles, 1 negative x tile, and 2 positive 1 tiles. Therefore, 2x squared minus 3x plus 2 plus 3x squared plus 2x will result to 5x squared minus x plus 2. So did you get our first 3 examples? Now, are you ready for round 2? Let's begin. Try to solve this following polynomials using the tiles to perform the operations on the polynomials. So let's try example number 1. 3x multiplied by x. So here, For us to solve the multiplication of polynomials using algebraic tiles, we just need a simple table. So above, to represent 3x, we just need to construct x by forming 3x tiles. To represent x, we just need to construct x by forming 1x tiles. So in the middle or inside the table, you are just going to put your answer there. This area or that area forms a rectangle. Therefore, you need to construct a rectangle with length 3x and x. So remember, when multiplying positive terms, it will also result to positive terms. So notice that you need to put 3x squared tiles that will fit together and will form a rectangle. So therefore, 3x multiplied by x will result to 3x squared. Now, try to solve this example. 3 minus x multiplied by x plus 2. Since it's a multiplication operation of polynomials, we need to put table for us to represent the operation using the algebraic tiles. So, to represent 3 minus x, we need to construct 3 minus x by forming 1 negative x tile and 3 positive 1 tiles. For us to represent x plus 2, we just need to construct x plus 2 by forming 1 x tile and 2 positive 1 tiles. So, in the middle or inside of the table, you are just going to put your answer there. So, that area forms a rectangle, therefore you need to create a rectangle using tiles. So remember, multiplying white tiles to black tiles will result to black tiles, just like multiplying positive numbers to negative numbers. Also remember that multiplying white tiles to white tiles will result to white tiles. So, as you can see or you will notice here that you need to put 1 negative x squared tile and 2 negative x tiles and 3 x tiles and 6 1 tiles that will fit together and will form a rectangle. So, we know that combining positive x and negative x will result to 0. So, therefore, 3 minus x multiplied by x plus 2 will result to negative x squared plus x plus 6. So, let's try this example number 3. So, in this example, we're going to divide a term to another term. So, x squared plus 7x plus 6 divide x plus 1. So, in division, unlike the multiplication, we have the missing part in the middle or inside the table. In division, we have the missing part in the top of the table. So, in the top of the table, we're just going to put your answer there. Use the tiles that will perfectly fit the rectangle. So, in the left side, you're just going to form the divisor or x plus 1 by putting 1 x tile and 1 tile. So, the dividend, which is x squared plus 7x plus 6, is placed in the rectangular area formed by putting 1 x squared tile, 7x tiles, and 6 1 tiles. So, remember, dividing white tile by a white tile will also result to a white tile. So, you will notice that the tile that will fit on the length of the dividend positive x squared tile and the length of the divisor x tile is x tile. So, it is placed on this area of the quotient. Take note that you should be able to create a rectangle. So, you need to put some more tiles in order to create a rectangle whose length is the same as the length of the whole dividend. Now, it is clear that you are going to put positive 1 tile. Continuing the process, you need to put 5 more positive tile in order to create a rectangle that will fit together. So, this is gonna be our quotient. So, after performing the process, it can be noticed that the rectangle on the quotient portion is composed of these tiles. So, therefore, x squared plus 7x plus 6 divided by x plus 1 is equal to x plus 6. So, I hope algebraic tiles will help you to solve different operations of polynomials. And now, be prepared and be ready to learn more about operations of polynomials.